people online, hopefully you can hear us well, and we've managed to avoid the problems that we had in the previous meeting. So welcome to everybody in person and online for this event. So aligning research and practice. Hopefully an interesting topic. Simone will just introduce the event, really. Yes.
Yeah, sure. Welcome to GAA. Thank you for coming. I think my part is to tell you that the exits are that way. There are no fire alarm tests program, so if it does ring, do head for the exits. We've got teas and coffees over there, and we'll take a quick break, I think, in between the two parts of the presentation. But there will be refreshments after the end of the meeting towards 6. If I remember, 4 to 6 at presentation. 6 we go and we can have refreshments in the bar.
Yeah. At the break, it'll be in here.
Break in here and refreshments at the end of the session. This was pretty much what I needed to say.
Okay, right.
And then you go, and then I may add something about aligning research and practice. Some thoughts about it.
Okay, so thank you, Simone. So brief outline of the programme. So Paul Littlefair, who was hoping to be here, really wanted him to be here, but sadly he can't make it, but he is going to give the voiceover from home for this. So his slides here, and we tried it out, so hopefully it should all be okay. So daylighting research into practice, the first sort of 50 years, current daylighting research landscape, 2 perspectives from BRE and academia, putting research into practice, how it sometimes, indeed often happens, not how we think. A break for about 10 minutes in here, and then part 2, the summary of the findings of the consultation, a number of short presentations from the consultation, including one of which will be remote, and fingers crossed that that should work well, and hopefully a lively discussion at the end. So any queries before we begin? I think someone's keeping an eye on the chat, so if there are any problems remotely, then hopefully we can sort of pick that up. Okay, so first we're handing over to Paul Littlefair from the BRE, who recently retired after, I think it was 42 years. And Paul really needs little introduction. Everybody knows who Paul is. So Paul, can you start on the presentation?
Yeah, thank you, John. Can you hear me, everybody?
Yes.
I'm really sorry I can't be with you today. I've caught COVID, so you wouldn't really want me there anyway. But I was looking forward to coming and meeting with you all, but sadly that wasn't to be. I've been asked to review 50 years of daylight research, and really we could do a couple of hours on this, but as time is short, I'm just going to pick out 8 pieces of research that have influenced practice in the UK, and I guess the things that daylight consultants do each day. And so that necessarily means that I've had to leave out lots of good research. Things like, for example, the International Daylight Measurement Programme that were really useful and underpin a lot of the other work that we do, but maybe they don't have such a direct impact on practice. So let's start with the next slide, John, please. Yeah, so I wanted to start way back in the mid-70s, and a study which Ralph Hopkinson, Elijah Neiman, and the wonderfully named Wendy Light did on people's reactions to sunlight in their homes. And they did this was a really big study, and it took a couple of years, I think. But they came up with the idea of annual probable sunlight hours, still widely used today. And they showed that a metric of 25% of annual probable sunlight hours correlated better with occupant satisfaction than other metrics current at the time, which were based on hours of sunlight on a specific date of the year. In my view, it's a shame that the new European standard hasn't taken this work into account and has gone back to the old type of metric based on specific number of hours of sunlight on a specified date. Next one, John. The next piece of research I wanted to highlight has been amazingly influential over the past 40 years. This was one of the first papers that I read when I started as a daylight researcher in 1979, and it changed my life. It's only a short paper, and one everybody should read, actually. But in it, Joe Lines introduces concepts of an average daylight factor, no skyline, and also the room depth criterion, all of which were later incorporated in the daylight standard BS 8206 Part 2. Joe wasn't the first person to propose the use of average daylight factor, but he popularized it, and an amended version of his formula has been widely adopted. And really, it democratized daylight. You didn't need special software or a maths degree, and designers could use it to generate the window area that was needed to obtain a particular level of daylight provision. So no need to do a sort of complex iterative process where you change things and then run a whole simulation again. Very influential piece of work. Next one. And yeah, apologise, but I've introduced one of my own pieces of work here because I think it has influenced what people do. It was written when I was a civil servant in the Department of the Environment, and we wanted to rewrite their guidance on planning for daylight. But it soon became clear that one of the main issues that people had was the loss of light to neighbouring properties. And so we produced guidance on that and introduced concepts like the vertical sky component to quantify loss of daylight to windows, and also areas of shadow in open spaces, both of which again are still widely used today. Next one, please, John. Yeah, this one is probably a less well-known piece of work, especially, well, in the UK it would be anyway. But it's really important for climate-based daylight modelling, because if you want to predict how much light gets inside a building, you need to know the sky luminance distribution, or how much light comes from different parts of the sky. And this depends on sun position and how much cloud there is. There's been a lot of good work on this, but Richard Perez's all-weather model is one of the most widely used because it does a reasonably good job for most types of weather conditions, and it's been shown to work well in different places worldwide. For this reason, it's often used under the bonnet in computational tools like Radiance, which is our subject of our next slide. So back in the 90s, Radiance was developed by Greg Ward, and John's probably going to say a bit more about this, so I won't go on about it, but most current daylight computation tools use Radiance as their calculation engine, and it's made it possible to do climate-based daylight modelling within a reasonable time frame. So obviously a very influential development. Next one, please. Climate-based daylight modelling is our next research development, and it's hard to pick a single paper on this, but I've included some of the earlier ones here. And these popularised the concept of daylight autonomy, which is the proportion of the year that a given daylight illuminance is exceeded indoors, and also useful daylight illuminance, which it's a similar thing, but it excludes illuminances that are maybe too high, as well as those that are too low. And Both ideas are used in daylight recommendations for schools in the UK. I think that's still the case. And daylight autonomy is one of the key ideas in the new European Standard EN 17037. On to the next one. Yeah, this has been an influential piece of work. It's a user study in US offices, asking people if they felt they had enough daylight. And they came up with recommendations for spatial daylight autonomy, which is the proportion of a space that meets a specific illuminance for half of annual daylight hours. And the illuminance that they found fitted best was 300 lux. And this value has found its way into IES recommendations in the States and also the European Standard EN 17037. For all sorts of buildings and location types, it's now used. And maybe this work has actually been too influential. It's just based on offices in the US, and most of them were in California in summer. So we need these Heschel Mahone people to come and do people's living rooms in places like Leeds as a follow-on study. So the final choice is work that's ongoing and just starting to be introduced in things like the Well Standard. Again, it's difficult to choose particular papers, and I've chosen one of the very earliest ones and a more recent work setting out the latest recommendations. It's the idea that daylight can influence our circadian rhythms, our cycle of sleeping and waking. Oddly, the way recommendations are often formulated doesn't always encourage use of daylight, because what they tend to do is to recommend a particular light level, maybe a melanomic equivalent daylight illuminance, but recommending a particular value that's got to be met for a particular time of day all the time. So all the time meaning every day, not at night, obviously, during the day. And the problem with daylight is that you can't always rely on it to do that, because in our climate we'll always get dull days when you're really not getting all that much from daylight. And paradoxically, what's possibly happened in the past is that people have ignored daylight as a way to achieve this. But nevertheless, it's clear that daylight is highly beneficial to our circadian rhythms and health in general. So I suppose this is a pointer to one area where daylight recommendations could be going in the future, incorporating circadian lighting concepts into the guidance we give. And clearly this is one area where more research is needed. So that's all I was going to say on this, and hand back to John.
Thank you very much, Paul. Right. A quick question for Paul. What, Jerome?
Is there much, on that last point, is there much research on the quantum of daylight that's needed to impact on circadian rhythm? I mean, how much light do you need to be exposed to for it to affect your circadian rhythm?
There's recommendations in the second reference, which is from 2022, and unfortunately I can't remember what those are, and maybe Cosmin knows them better than I do. But it's given in terms of a specific illuminance from daylight. I think it might be. Well, I'm not going to make it up. You'll have to look at the paper.
It's around 250 lux, I think. And I think Tim Brown's paper is the most authoritative one. It's kind of a meta study of, but it's all based on melatonin suppression, and the obverse of that in terms of being alert and everything else, as Tim Brown emphasizes in that paper, but often gets overlooked, is pure supposition. It's never actually has yet to be proved. We kind of feel it, we know, and all of that, but the mechanism is purely about melatonin. And the whole obverse part of, the wakey side of light is yet to be fully established why we have this, why we feel this. Okay, so thank you very much, Paul. And now everybody, including Paul, can just ensure that their microphones are on mute if they could. And I'll hand over to Cosmin, who, well, essentially Paul handed over to Cosmin. So if you want to use the clicker, there you go. Well, actually, once they're there, yeah, fine. Yeah,
If you want people to see you, you can either sit there or stand there.
Yeah.
Sure. Better than this side.
Yeah.
Okay.
Okay, hello everyone. So I'm supposed to talk up to 10 minutes, for up to 10 minutes, hopefully. I haven't timed myself, so I'll try to be quick. About some research projects that we've done at the BRE over the last, 15 years, roughly. This is just a list showing some project titles for the research work that we've done, again, over the last 15 years or so. Mostly it's about field studies and computer modeling of technical and human factor aspects of lighting. It's not just daylight. I'll try to focus on daylight in the next slides. But this is just to give you an idea of what the types of topic that we can address. Obviously, to do this research work, we need appropriate funding, and I just wanted to add a bit on that, saying that most of these research projects that we've done were funded by the BRE Trust or CIBSE. So we're lucky enough to get support from these organizations. In some occasions, the projects were funded by commercial clients as well. And actually, just one quick note on that, we have recently BRE has recently registered as a RTO, Research and Technology Organization with UKRI. So basically, what that means is that we are eligible to apply for funding similar to university whenever there is a relevant opportunity. Okay, so let's have a look at some examples of research that we've done over the last years. This is something that we did about 10 years ago. This work was funded by CIBSE and the BRE Trust to assess new methods, new methods for daylight prediction. Basically, what we did, we just compared the more traditional methods based on the daylight factor against the then recent developments in this area. One being this LENI, Lighting Energy Numeric Indicator, which had a daylight component in it to assess energy use for lighting in buildings, and also climate-based daylight modeling. And to do that, we just use a lot of room models. We did a lot of computer modeling to assess or to try to predict daylight levels using these methods, and also to calculate the energy used for electric lighting in those daylit spaces. And basically what we did find in this project was that there were many problems with LENI in EN 15193. That was a I can't remember, that was the initial version anyway, but subsequently it was revised, this standard. So nowadays it's much better than it used to be. And we also found that CBDM was had really good potential at predicting daylight in buildings, but you had to be very careful in terms of how you word the recommendations, because that can have a very big influence on the results. This is a project we did after that. This is something which isn't specific to lighting. This was there was an opportunity at BRE to take one of the spaces using biofluid design principles. Lighting was just one element to it, in addition to others like materials, finishes, furniture, and so on, acoustics, and others. We had a range of industry partners in this, and the idea was to have a pre-refurbishment phase and a post-refurbishment phase, obviously with the refurbishment in the middle. We were able to complete the first phase, the pre-refurbishment monitoring and assessment. Sadly, the project ended at the refurbishment phase, so we weren't able to continue with this. But we were able to actually take that floor plate, which you can see there, and do a lot of detailed work on it. Daylight and electric lighting as well. As regards daylight, we did computer modeling of daylight in those spaces, and we also, well, we still have that monitoring arrangement, which you can see in those pictures there, to record levels of outdoor illuminance, horizontal and vertical, facing all main directions, cardinal directions, and also indoor illuminance. And we had a few other things like loose devices, if you're familiar with them, just to record the individual light exposure and so on. And we also did that detailed computer modeling of daylight, including annual profiles of daylight illuminance at the eye level of those occupants to see what happens in terms of those circadian effects that Paul mentioned earlier. This isn't necessarily daylight, it's artificial skylights, but I think there is a certain parallel which can be drawn with daylight, roof lights particularly. This is something that stemmed from the Biophilic Office project. One of the core partners in recommended products wanted us to test those products for impacts on cognitive performance of office workers and the overall appearance of the space. So what we did, we had a couple of rooms at the BRE. You can see the images there. Here is the control room with LED luminaires, same there. And this image here shows the control space with those artificial skylights installed. Everything, we try to match them. The rooms are identical. Light levels, illuminances on the desks as well. Obviously, the distribution of light is different. But anyway, just to cut the story short, we did cognitive testing and a lot of questionnaire-based qualitative surveys, as well as detailed assessment of lighting and monitoring of environmental conditions. And we actually did find that even if there weren't clear statistically significant differences between the two rooms in terms of cognitive performance, we actually found that those artificial skylights had the potential to help improve mood, alertness, and overall well-being of the office occupants. And we had two phases in this: long-term effects, where participants were exposed to these conditions for a week in each room, and short-term, half a day in each room. This is more recent work. We were supported by CIBSE, so this is a fully funded. This is a project fully funded by CIBSE, in which we assessed the two daylight calculation methods in PN 17037. The idea for this was to actually see whether you get different results by using the two methods, and also provide guidance for daylight practitioners on how to apply these methods. We looked at, we used a number of models, room models for this, with different site orientations and different levels of external obstruction, to investigate the effects of computational parameters, the size of the ground plane, the position and spacing of the grids, the calculation grids, as well as the weather data sets. And the key findings, there is a research insight published by CIBSE, which you can look at in detail. The main findings were that obviously there were differences in results, and actually it was in most cases easier to meet the recommendations by using the daylight illuminance method. We also used some of the findings to inform the latest edition of our guide, Site Layout Planning for Daylight and Sunlight. This is a project which isn't necessarily about daylight, but it's about electric lighting, variable electric lighting, which was supposed to mimic daylight variation throughout the day. So again, supported by CIBSE and the BRE Trust in this one, we investigated potential impacts of variable lighting on health and well-being and performance in an office space at the University of East Anglia. This was basically, we compared the old constant fluorescent lighting, which you can see in that picture there, against LED, dynamic LED lighting, which we set different conditions to give certain light levels. The main finding of this study was that, well, we didn't find statistically significant differences. I mean, many of those, but we did find a statistically significant difference in subjective alertness between the old and the new lighting. So again, subjective alertness. We also found that people under the new lighting felt better overall. So there was a preference for this dynamic lighting or variable lighting. And interestingly, looking at the conditions we tested, they prefer to have something bright in the morning and then following somehow the variation of daylight throughout the day. So even if it's not daylight, it's something like daylight. So this gives us an indication of what people might prefer in spaces. And this is the last project I'm going to show you now. This is, if you wish, a combination. Let's say we got some inspiration from the last two projects I've just shown you to look at well, circadian effects of indoor daylight levels in offices. So for this, we used a selection of the room models we used in the CIBSE, let's call it CIBSE project on the daylight methods in EN 17037 to check whether they would also comply with the latest recommendations by Brown et al. That Paul mentioned earlier. So that was again published in 2022. And just to respond, to your question, Jerome, it's 250 lux, as you also said, John, melanopic equivalent light luminance LDIs during the day. The thing is, they don't specifically say for how many hours and all these details. They only say 10 lux AMDI 3 hours before bedtime, for instance, and 1 lux AMDI during at nighttime during sleep for the sleep environment. But the question is, what does it mean to 50 lux AMDI during the day? So what we tried in this, we also used some measurement data. Paul mentioned earlier the IMDP project. Measurements were taken at a number of locations. BRE, I think, was one of them. So we had measurement data for illuminances from daylight, outdoor illuminances, and we tried to come up with a reasonable level, because as Paul mentioned earlier, it's unreliable or unrealistic to require a certain level from daylight every day of the year. So we said, okay, why don't we say 90% of annual days? And we tried to see in those spaces that I mentioned. So basically, one was an office space meeting the minimum level in EN 17037, and the other was meeting the high level of recommendation. And we wanted to see whether these spaces would also provide this 250 lux AMDI at the eye level for different view directions and different sight orientations, which is basically linked with the level of obstruction outdoors. And just to cut this short, what we found was that the office with a high level, which meets the high level of recommendation in 17037, has the potential to provide, to make it possible to achieve this, to meet these recommendations, the 250 lux AMDI, over 4 hours a day. Now, 4 hours, where this comes from is the well-being standard, because they came up with this idea of recommending this light level over 4 hours a day, preferably in the morning. This is another discussion. Again, a lot of research is still needed to come up with clear evidence. But we wanted to try this and see what we get. So we did get this finding that, if you meet high level, you are more likely to provide sufficient daylight for circadian entrainment. But then, and if you face, if you are in this office space facing the window and ideally unobstructed window, so it matters. The way in which people are facing is important, and what obstructions there are outside, and so on. So, but this comes with a problem. There is a higher risk of glare, which obviously may mean people will, close the blinds and so that stimulations, again, stimulation may disappear. So it's a discussion here, but at least from a design perspective, if you look at the apertures without taking the blinds into account, it may be possible to provide this level for circadian stimulation by aiming for a high level of recommendation. The other rooms didn't meet that. And it was easier to achieve that if you take into account, if you try to get this light level over any 4 hours during this occupancy hours from 8 to 6, rather than the morning hours, which is much more difficult to achieve. So yeah, and there is, well, this is work in progress at the moment. We are trying to publish this in LRNT, so hopefully in the next few months there will be a paper describing this work in more detail. And that's all from me. I hope it wasn't more than 10 minutes.
Any quick questions, Cosmin? Okay, you're off the hook.
Okay.
Right, Mandana. Right. Now, I'd say I put Mandana on the spot here a little bit because we were last minute with the slides, and I employed editor's prerogative, and sort of academics always do too much. So anyway, I trimmed. You can see what's coming next on there.
Yes,
so,
I will.
So Mandana Sarik Khan.
Yeah, Mandana Sarikani
From UCL.
And this is still Cosmin.
So yeah, no, just use those to go. Yeah.
Okay.
So
That's
then you can see what's coming next.
Okay.
Yeah,
Oh,
you do it
yes.
sitting down if you want, whichever.
Yeah.
But I mean, just say what you're going to say, but let's just use them.
Yeah. Well, when you have senior academics, they always have to tell you what to do and what not to do, even if you have had some years already of experience. But that's how it is. And I can see that my slides are probably a lot shorter than what I had initially intended to talk about. But the idea was to give you a little bit of overview of what are the points of view from academia, what kind of projects, of course, we are doing at UCL, and also from my experience beforehand. I arrived to London 6 months ago, and before that I was at D2, and before that I was in Switzerland. So this already creates a lot of different academic exposures, let's say, to research and also practice at the same time. And aligning research and practice would be one of the things that is a hot topic for us from the research side as well, because if what we are doing research about is not going to be used, or there are like large gaps in there, then of course that would be a problem. So one of the
I think there's a mouse button that's been pressed. That's fine now. Yeah, just press it.
Yeah, okay. One of the initially, personally, I had worked a lot with gaze behavior, trying to understand and decode it in a built environment. And one of the outcome of that was that people look a lot more outside than they would look inside, as long as there are medium range luminances to be able to look at, and they would avoid it while if there are glary situations. So this kind of shaped the idea of perhaps view is also a more important thing to look at instead of glare, and we need to understand the usage of shading devices in relation to glare, and in relation to view, as much as we are doing it in relation to glare. So this was a series of studies that we did where we are trying to characterize the view in relation to different shading devices. So the view itself and the quality of the view is not at question, it is like how it is perceived or how different shading devices would affect that. Yes, and as I said, it initiated by looking at the gaze behavior and by decoding, of course, this image is representative of that. This is what a person would look like, look at the space in really short, like less than a minute of time. So what we do is basically scanning the whole space without even noticing it. So that's why gaze behavior could be an interesting indication of preferences indoors. We've tried to look at this or expand it into understand like how it can be used in practice by looking at how it can be implemented in rendering and design phases, by also trying to look at cross-camera tracing methods which can enable to extract this kind of information of where people are looking at and how that can be used. And as Cosmin was mentioning, or the question came up related to MEDI, this is the measurement that we want at the eye. So it's more and more important to, or it could be very important to have this information one way or the other. And these cross-camera tracing methods could be one of them. And we also looked at VR a little bit, how this kind of information can be implemented there and how can it be used in practice. And again, one of the important parts that we looked at was the view, because we know that view has not only financial values for us, it's a food for the eye, it changes our perception. Different study shows that people have expressed less comfort or less discomfort when the view was more agreeable in terms of both thermal and visual comfort. And as I mentioned, gaze behavior has also been affected by presence of view. And a bit more detail about the study that I was just mentioning with the shading devices. So one way of looking at it and to be able to use it for building operations is to how what is the amount of view that is required when you have different shadings, and also what is how the different shading types would affect it. And in this specific study, of course, we looked at different shading devices, but we also were trying to understand how this perception was changing if people were looking at the shading devices from different ways. So that's why is view direction resolved. Again, in practice, it's really important to be able to communicate this data. So one side is the research and the information we get, and the other side is about how it's communicated. So in all of those, we are trying to always look at the best way that the communication can go. So this comes from the same study with the shadings and with the view, trying to understand where people are sitting in the view, what are they exposed to, and what that orientation within the space would mean in terms of different parameters, a combination of them. It's really important to look as a combined, so to have a better understanding. This again.
You just have to touch it and it goes into it. So just avoid that button.
Yeah,
just that one there.
I'll try to avoid it. And here you can see the results of what are the predictions. The predictions here we had was for glare, for MEDI, and the Q1 is a model that we derived for the view evaluation based on our own data. What does the prediction says and what does the self-assessment say? So it is always important to validate these methods on a field study and look also again at them and if they are predicting the same thing. So there are 2 points to make here: how the results are communicated, or 3 points: how the results are communicated, how the combination of different information are needed to make the right decision in practice. And again, validating is very important when you're coming from the research side. To expand this in relation with trying to expand the studies with other groups internationally, we are working, or I'm personally working with different groups through mainly International Energy Agency. One of them, and they normally embark a lot of new routes in research to take, and each of them are important to follow, and again, the combination of to practice. A visual disposition is something that we are looking at the moment together with Lund University, or we have started talking about. It's a really important aspect. We all have different visual systems. We see things differently, and this is normally not taken properly into account when we are doing a lot of our experiments. And doing these kind of differences and understanding the needs and requirements of human, I think even at this detail is very important. So these are a series of recommendations that we want to put forward to look at the visual system differences in terms of visual acuity, contrast, sensitivity, etc., and what is needed. Another project that is coming up is looking at passive facades and also looking at more different ways of controlling the shading systems, mainly at the personalized level, if possible. So it might not in practice be, I don't know how realistic it is, considering that the usage of shading devices is already by itself problematic, or there are different views around it, but this is quite interesting to follow up. Another project that I want to mention was about the view quality itself. We know that in EN, of course, the standards currently, there are ways of accounting for view access. However, the way it is defined now, it can be improved. And this study is looking into that, like how the access to the view can be defined in a way that it's not compromised at the end. I don't know how many more slides, John, have you left me? And it's like,
got a few there.
Yeah, I guess I got 2 more. In this one is particularly UCL is not as much involved in it, but looking at the window view from in the different urban contexts and trying to quantify the urban morphology. Showing how much, of course, access to sky, ground, vegetation there is, but also movement, urban landmarks, and art, how to account for them in the view context. And another group is looking at a more dynamic way of making the same assessment. Yeah, it's important to look at this one as well. In this project, within the same context of a collaborative work that we are doing, the idea is to put simulation and measurements together. I guess, John, you will talk about this later, but with the new possibilities that we have on simulation through radiance, the hyperspectra calculations with radiance, the idea is to do simulation on existing measured buildings among the whole group, and this would be several of the research groups in Italy, in UK, in Norway, etc. We are all involved in this. That they have done studies related to circadian lighting, and they have done sophisticated measurements. But then we want to also combine this with simulation. And finally, within the same type of studies that we are doing, the same list is about the measurement and assessment methods for the circadian lighting, and or what we could also call the non-visual aspects. There is lack of understanding of which of the existing new measurement devices are working best for doing this kind of research, and the focus on this activity is mainly on that. So that was all from my side. I kind of wrapped it together. It was very difficult, but thank you so much.
So do you have any questions for Mandana?
Yes.
A very quick one. How do all of these really interesting and diverse studies get selected as an area of research?
Really good questions. Normally, well, how do they get selected is, I guess, what John will talk about. about you know, like I think it's on the research side, of course, we always come with a proposal and applications, and I don't know exactly how they selected, but there are many parameters. I'm not sure if I get the question. I mean, you know, I mean, we know that what is the niche or what are the gaps, and then we put the projects forward, and hopefully they will. The selection committee will agree with that. So they don't come from, you know, they come from where the trends are maybe when we want to address these kind of questions, and so they kind of align.
In academia.
No, well, here I guess it's UKRI who is funding most of the projects. In different countries is again the funding bodies. There are different funding bodies. It's mainly a national funding body. That it could be from philanthropic kind of side that they would allocate some money for research. So there are different funding resources to go for. There are EU fundings for it. So there are fundings out there for. And a lot of time with industry, we have a lot of collaborations to get funding together because there are some questions that you have, and then we could answer them, and then we can combine the efforts together. So many various ways.
If I was to put a plant in for this to ask a question for what's coming next, it would be Simone there sitting there. So yes, it does.
It wasn't a plan, but we
Was there another one? I think somebody else.
Be on the chat.
Okay.
Have we got one on there?
So this.
I would be keen to understand if there has been any research into the relationship between ensuring access to daylight and reducing overheating. Yeah, of course, there are several attempts. I mean, these are some of the examples that I showed, but we on a lot more simulation based is possible to look into that, and I think a lot of studies have been done to understand how we can optimize daylight access and overheating. But it's a very interesting, of course, trajectory of research to follow. In the study in DTU with Rone Andersen, when comparing predicted glare and view access, okay, it's many questions coming up. We see many discrepancies in the results you showed. Could you explain those differences?
Maybe I can explain. I can explain my question directly. I don't know if I understood correctly the results that you showed, but you said that it's important that the results are communicated to people, and it's important to validate them. And so, if I understood correctly, you wanted to compare the predicted indicators with the circles. I don't know if you see which slide I'm talking about. Yeah, this one. This one, yeah. And the self-assessed. And for me, they look quite different. And so I was wondering if it was a validation for you or not. And if not, could you find the origin of the discrepancies?
Yes, in this case, what was clear was not that the lack of proper measurements of the materials. So this was a library setting and a lot of other parameters that, I mean, we had control on many of the indoor environment parameters. So the thermal comfort, CO2 levels, the air quality, humidity, etc. These were monitored, all of them. So it doesn't come necessarily from that, but it comes from at least one theory that what we think is that how we have inputted the materials in the in some of the study is not accurate, and the number of the sample that we have is very small, so we did not even put this in a paper in a way that was it significant or it wasn't. We didn't look at it statistically, but we basically used the data to show this graphically how it can be shown. And it was a MSc project, so it was a master student, and it would be interesting to follow it up. And I, normally use it to kind of highlight the fact that we need to do this kind of study a lot more. And this towards that, yes.
I think we're going to have to move on with that. But
Yeah.
I mean, perhaps we can get back to the questions later
Yeah,
on
sure.
and responded on the text or
Yeah,
in the
definitely.
discussion. Okay,
Thank you.
thank you. Thank you, Mandar.
Thank you.
Yes. How it sometimes, or indeed often happens. So the rational model is as follows. So the research landscape is seen to have a gap. So we think, what could possibly fill this gap? Well, you've already thought of what you want. So that immediately constrains the imagination. Now, of course, you need some incentive to get people going. And so you put that money on the table, you have a bidding process, people eligible, a lot of academics, they gather around this, and the lucky person gets the grant, don't forget the money, goes off, does the research. Everybody comes back after 3 years, however long it was, might be 2, 1, and then lo and behold, the gap is filled, and hurrah, everyone's happy. I don't know if a research project has ever been officially one that didn't work. All of them seem to work. So that's interesting in itself. But what happens in the real world? Getting from there to there, we actually look at how it happens. In a few cases, it's not straightforward. The landscape looks like that. There's many ways through it. Most of them lead to dead ends. But importantly, there'll be gatekeepers, and you probably won't even know who they are. I certainly didn't. I mean, the people who were the gatekeepers at the Education Funding Agency, I wasn't involved in this, but even if I was, I would never have known who they were. So let's look back at something that clearly has made an enormous difference. Radiance. Now, everyone's familiar with radiance, yes. Everyone is probably familiar with Mr. Radiance. He's Mr. Radiance. He's not Dr. Radiance. Mr. Greg Ward, who was a staff scientist at LBNL when first version of Radiance came out at about 1989. Now, back then, early 80s, late 90s, oh, I shouldn't have pressed that one. There we go. You had radiance, you had radiosity. One person, Greg Ward, was doing radiance. Radiosity is a completely different solution method. I went to a couple of graphics conferences in the early 90s and then stopped going because they weren't about anything that actually were helping in the stuff I wanted to do with radiance. Everybody was doing radiosity. Hundreds of groups all around the world. How is it that all of this money, effort, everything else went into kind of reinventing this wheel? I mean, it's right that you have people doing the same things because that's reproducibility and whatever. But it just seemed ridiculously unbalanced. And not only that, but you look mid-2000s, first 2005, by around that time, anybody who's doing anything interesting in lighting simulation is using radiance. Radiosity packages, well, they didn't really exist. There was, I think, both Thorne and Philips spent each hundreds of thousands of pounds to build on top of the academic investment already spent to develop end-user systems for visualization of lighting setups. They all failed. Now, that story has never really been told. I mean, people sort of, occasionally reminisce in the bar, especially after the Radiance workshop about this. How is it that you ended up with a situation like that? Well, it wasn't just that. I mean, we used to call it the curse of Radiance. You start working with Radiance, you never get funded. And that was certainly my case. So the validation, that helped to to really establish radiance in practice, because its accuracy, its potential accuracy, very high accuracy within plus or minus 10%, which is astonishing, could be demonstrated. And that only happened because there was that fantastic data set collected by the BRE. About all that work that I did on that was all done unfunded in the evenings. My daytime job was marine ecosystems modelling and zoology, part of Aberdeen University at the Marine Lab in Aberdeen. There we go. Similarly, CBDM, the development of that all happened. Other things. Now, this actually was a bit of funded work, but again, not grant funded. Anyone recognise this building? This was it in 2018-19. Central Park Tower, New York, West 57th Street. It's the world's tallest residential building. I think it just topped, well, I think got finished off about a year and a half ago. Second tallest building in the US. I think its total cost was $3 billion. It's right next to the Art Student League building, 1875, which has some roof lights on top of it. And the users of this building were concerned about the loss of daylight, because artists love daylight and they like painting by daylight. So they were concerned about the loss of light, and they wanted some measure which they could use in their negotiations with developers, and possibly also to reduce, because look, I mean, cantilever over there, that loss. And the people who are a not-for-profit group who were advising the users of the building knew about the stuff I was doing completely independently of the New York Times, which happened around the same time, and said, could we use your climate-based? I said, sure. It's like putting a light meter on the window, leaving it there for an hour, for each hour in the whole year, every hour totting up. You get a lux hours value for the whole year. And you do that then with and without the tower. You can see the difference. You can have a black tower and a reflective tower. Turned out those numbers showed that actually if you had a reflective facade around here close to the skylights, you could halve the loss through into reflection, around 50%, which is about tops for an external weathered surface. That figured in the legal agreement for the development of this building. So that started off in 2005, then 2008 crash, everything on hold. 2013 it came back, and so the final design, which was cantilevered, had to be reevaluated. And so it was, and it showed actually it was no worse than what had been agreed. So as far as I'm aware, it's the first and probably still the only building where a climate-based measure is figured in the legal agreement for its development, but it's one heck of a building. You can't really ignore it. How did it happen? 18 months before, I sent the people who were advising this lot an email saying, I've just seen your fantastic models of Manhattan 3D. I was using a model of San Francisco, which in the late 90s was pretty complex, but this was order of magnitude or two. Could I try out my techniques on your model? And they said, no. Go away. We license stuff. You'll have to pay. I said, well, no, I haven't got anything to pay with. I went, more. So, but then they remembered about and then got back to me. That's how it happened. You can't plan for these things. So New York Times, that was an intense research project. Again, not funded in a normal way with grants. Well, not as far as I was concerned. LBNL did all of the sort of legwork, putting the proposal together and all of this, but I did this insane, intense amount of simulation work. I think 140 gigabytes of simulated data was crunched through for all the analysis that was done there. So it showed a load of stuff, but it showed what was possible with lighting simulation. So it was a landmark event. And again, it happened, well, not in a steady, we're going to plan this out. It was more just bang, this is going to happen. We need to do this quickly. And so you actually agreed to do things and you weren't even quite sure if you could do them. Now, why is funding the way it is? I think part of it is it tends to fund, therefore reward, familiarity and fashion. This is, you know, again, there's no conspiracy. This is a human thing. This is what happens. I mean, I don't know for certain what happened, but certainly with radiosity, the idea goes back to the 1950s, thermal transfer. It's when they were first thinking of putting up satellites, and the satellites were exposed to incredible thermal environments where they're in sun and they're not in sun, and it was purely radiative. There's obviously no convection going on in there, so that simplified things. So the basic idea is you could solve analytically for simple shapes, especially cuboid. So all those kind of ideas exist. So when radiosity gets implemented in computer graphics, you've got familiarity immediately. And so the funding bodies, when they start, yeah, I know what's going on here, but when there's this Mr. bloke who we've never heard of doing something a bit different, when things are different, that can sometimes be a bit of a disadvantage. Radiance end user tools. Oh, I stopped counting at about 10 or 12. This is when funding councils went down the fashionable route, became fashionable in the sort of mid-90s. So fund end user tools. Universities are the worst place for end user tools. Because for start, the work only exists during the period of the grant. And let's just say some people picked up your tool and started using it. They're going to want support afterwards. You know, it's very, I mean, there are a few exceptions like ESP software, Joe, the energy simulation, Joe, Joe Clark at Strathclyde. And of course radiance, but again that wasn't happening, that wasn't being supported in this sort of way. So universities really were, universities about ideas, not about producing bits of software. They don't have those skills, so an awful lot of that they just ended up in the software graveyard even before the project had finished. That was the sort of fashionable part. Now, anyone here heard of the Research Excellence Framework? It's a big thing universities do every 6 or 7 years, and it consumes the life out of them. I mean, it's a huge exercise, and it's to determine the impact of research, first in terms of publications, but then they also have this real world impact case studies. Now, if you put in an impact case study and you actually show that you did it with very little money, or actually, well, in my case, to vindicate a system. And so what people do, they will pack that grant section full of millions and millions and to show that this all works. Now, it's such a small number that's self-selected that inevitably you're just going to get things that, you know, I've got a chance of shining and standing up that go out to these panels. It's very hard to assess research efficiency, but it would be good, I think, if we started at least trying to do that. Another thing is the pressure on academics. This was the title of an opinion piece in American journal, scientific journal from 2016. I'll put the link on the LinkedIn and the chat thing on after this, or maybe tomorrow. Academics now, you know, they need to be seen to be doing stuff. Previously, academics did stuff, thought about it, that was it, and then boom, there it goes. Now there's this constant, almost presence. You know, there's a strongly performative aspect to academic life now. You know, you need to be seen to be doing this stuff. And lastly, hopefully that's not a contentious proposal, suggestion that 9 nuclear Nobel laureates can't be entirely dim. Why did 9 get together? 9 got together and they wrote a letter of stinging criticism about the state of funding and the way it was done in the UK. They said that the funding bodies were just picking favourites, following fashion, blah, 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 and the system needed urgent reform. As far as I'm aware, they never even received an official reply. Now, academics moan about this constantly. but they don't moan about it openly, right? Just talk about the biggest guns you can get before they put their heads over the parapet to do that. But yeah, we need to think about some way of doing this a bit better, and a more devolved bottom-up approach, possibly where you actually give, university, actually you get a sort of research stipend, which starts to make sense when you can combine it with that from 2 or 3 other people, and then you maybe have got enough to buy an RA, a research assistant for a year, but to create a sort of a grassroots market amongst academics, where they've got a little research pot, and then if they've shown they can use that well, and also that the people who assess this are not so far away, because when you've got people assessing, or deciding policy, and they're so far removed from what happens on the ground, you're going to get situations, like we have at the moment. And just before we break here, now, having left academia, I can indulge in a little bit of heresy and stuff, and say things that you never would have done when you were there. And the real heresy in all of this, I actually had this conversation by email with Greg Ward actually just a couple of weeks ago, and we were talking about this, about the whole funding, and he said, yeah, it was just brutal the way, getting through from day to day, and I said, well, yeah, and I think that too. I mean, I just got a bit fed up. I constantly had people on my back because I didn't have the grants with overhead, so I was bringing in a lot of consultancy work, whatever. Ceased to think, okay, well, not bad, that impact, despite the fact we didn't get funding. But then the real heresy is, actually, maybe it's not despite, maybe it's because if you don't get the funding, you don't end up in what increasingly can become a sort of academic hall of mirrors. Again, it's not criticism of people in academia or whatever, it's just the way things develop. But if you don't have funding, first you can just do what the heck you want. So you're not going to do incremental, you're just going to do the fun stuff. And of course, the way you get by is by engaging with real world activities. So that happened, right from day one. The big difference between radiosity, the other big difference in radiance was real world stuff was happening almost from day one with radiance. The cover of that radiance book was done by Rob Shakespeare. So at the same time I was tinkering back in the early 90s, Rob Shakespeare was using radiance for theatre lighting design, all these fantastic effects with gobos and all these other sort of things that can alter the patterns of light. He was putting them into this physical modelling and producing these amazing simulations. So we have a break of about 10 minutes. And I've left university so I don't have to look in my pigeonhole for a P45 at the end of it.